first stage was sighted by helicopters about 25 miles away from the newest ship. This is the latest information we have, the newest ship. This is the latest information we have on that. The crew selection for Apollo 11 has not been made. The crew selections to 10 have been made or not. They have not been made beyond that. I apologize for anyone okay, one over here, because we've neglected you, and that'll be the final one. And I apologize to the rest of you, but we have to look after everybody's desires on this, and I think we'll have to get back to the mission.
Apollo 8, Houston.
America's military
Go ahead, Houston, Apollo 8.
All
right, Frank, you could help us out if you'd explain where you are relative to the booster. In other words, with respect to the Earth and the radius vector, are you above or below or to one side, or where exactly is the booster relative to you?
I believe that
Well, the trouble is, as I said before, we can't definitely find the Earth. I think that we're in front and a little bit above the, or almost in front of, directly in front of the booster.
I
understand, almost directly in front of the booster.
A part of our total strength.
Perhaps a little bit
I believe that
horizontally displaced
national strength
toward the
between nations.
Let's see.
Partly in the minds of men, and is what people think is your strength. And I believe that our ability or lack of ability, as compared with the other nations, to carry out space operations, constitutes a very important part of our national strength. And all of those comments, I believe that
Houston, to help you, we're looking right directly above the S4B when the sun is on our, it's on the right side of the S4B and on our, coming in our left number one window.
Large step closer to...
Okay, I understand the sun is on the right side of the S4B and coming in your number one window. And are you, when you give us those angles, that means that your plus x-axis is pointed at it with those angles, is that correct? Right. Okay.
General, I thought you had some closing remarks you wanted to make. If I may, and this question is a good basis for saying it, the Apollo 8 mission is...
The Earth is in our plus Y plus Z direction now, Mike.
As a step.
Thank you. Earth is plus Y plus Z.
With my own confidence continues to be high, we will be able to carry out sometime next year. I also believe that Apollo 8 and each of the manned flights is important to the country as a whole. Not only to the Apollo mission, the progress study of the landing, but important to the country. And I believe that the people who made it possible for this mission to fly and take off right on time deserve a tremendous amount of credit. People, in fact, go back over months and even years that deserve a tremendous amount of credit. But over the weeks that this vehicle has been put together, checked out, and made ready to fly this year, I think it's been serially outstanding work done. And I'm certainly proud of the organization, and I believe that the country should also give the people here at KSC, both government and industry, a vote of thanks for getting this mission off. Thank you, sir. Over the drone of the engine, I have one other announcement to make, and that is that Mrs. Marilyn Lovell, the wife of astronaut Tim Lovell, is in the Cocoa Beach area, and she will be happy to meet with the news media at 2 p.m. this afternoon. The location will be at the pool at the Holiday Inn in Cocoa Beach. Thank you very much.
Houston, for information, I'm looking through the scanning telescope now, and I see millions of stars, most of them the vending from the S4B.
All right, do you have any trouble telling which are the stars and which are S4B particles?
Oh, yeah, well, definitely. We're in sunlight, and it looks like they're all S4B, but we don't know. I'm going to attempt the B-52 real live at this time and see what I can do.
I understand, Jim.
More than that, we've been occupied with trying to understand what a proper maneuver would be to give us added separation from the S4B. Foreman reported some 15-20 minutes ago that he thought the S4B was staying a little bit too close for comfort. He estimated its distance from the spacecraft 500 to 1,000 feet, and he said he was viewing quite a lot of venting, not propulsive venting, but just great clouds of venting coming from the S4B. He later reported it stopped. In the course of the last 20 to 25 minutes, we have been playing music on the VHF, by VHF out of California. The crew reports Herb Alpert sounds great. We came to him just a little bit north of his native Tijuana. So that system, we're trying to find out just how far out in space the VHF will carry. Certainly the quote that stopped us all, more so than anything else, came from Foreman. I'm sure it was by accident. But at one point he, in trying to configure for a slight burn to give him added separation from the S4B, Foreman says, as soon as we find the Earth, we'll do it. That brought a loud clap of laughter here. Here's quite a lot of tape coming back over the last 17 or 18 minutes.
Stand by one, honey. That's a permanent mic on 247. We're working on an exact ABC of that.
Mike, anything more on this separation maneuver you want?
So we're working on it, Frank. We're trying to compute what radially outward will be in close terms. Now, you still have the Earth, as I understand, plus y and plus z quadrant. In other words, it's down below you on your right and slightly to your rear. Is that still true?
That's right. Quite a bit to our rear and down below us. Right.
Okay, well, we, of course, in that attitude would want to burn some upward and some to the left, but we're trying to be more precise than that.
So I can write it down, please shoot.
All right, big vent time, 5:07:55, and it will be, Frank, is it still about the same distance away? Are you opening or closing? 44.
It sure is staying close to it.
Understand. And Bill's got the tape recorder back.
Mike, can you just tell us which way the S4B pitches and how far it'll pitch to the slingshot maneuver attitude?
Roger, stand by.
I guess we're between 500 to 1,000 feet. Roger. Pretty good.
Frank, your S4B is within 10 degrees of its final attitude at this time.
Okay, thank you. Houston, you ready to copy the IMU line information?
Go ahead.
All right, star ID 03 and star 36, star angle difference 0.01, torquing angles X minus 00034, Y minus 0027, Z plus 00100, over.
Okay, thank you. For Y, I just got 4 digits, 0027.
Houston, Apollo 300027.
Thank you.
I believe we're going to have to bend or thrust away. Houston, we're going to have to hold up with the system navigation until after this next.
I understand, Frank. Roger, Jim, we understand. Give us some idea of when you did it and how much. Apollo 8, Houston, could you stand by one? Houston. Could you give us an updated readout of your gimbal angles when your plus x-axis is pointed toward the booster, please?
All right, stand by.
oriented to perform a electric blowdown. Is it still tracing? Does it look like it's closing or anything? Holloway, Houston.
Go ahead, Houston.
Could you give us those gimbal angles, Frank, when you get a chance?
I'm getting the coax right on it now, so we'll be accurate. Houston,
Thank you.
The bending on the S4B is terminated.
Right there, Frank.
Okay, with the coax right on the S4B, the roll reads 105. The pitch is 275, and the yaw is about 325.
Roger, copy, roll 105, pitch 275, and yaw 325.
Roger. That should be 115 for the roll.
Thank you, 115 roll.
Apollo 8, over. Away from this thing a little bit, although it's still pointing out at the black closer to the right.
Apollo 8, Houston, go ahead.
Roger, Bill, help me on your mic. The Earth is plus Y about 45 degrees to minus X, and I can see it out my side window. And it's a beautiful view with numerous cloud vortex. About 320.
Roger, Bill, thank you. I understand plus X 45 degrees between, in other words, halfway between plus Y and plus Z and slightly minus X?
Negative, it's 45 degrees in the plus Y, in the XY plane towards
Frank,
minus
you could
X.
help us out if you'd explain where you understand the XY plane toward X, 45 degrees. With respect to the Earth and the radius vector, are you
45 degrees from plus Y to minus X.
Roger, thank you.
Well, the trouble as I said before, we just behind us to the right, if that'll help.
Roger.
We're in front and a little bit above the, or almost in front of, directly in front of the,
I understand, almost directly in front of the building.
I can still see the Cape and isthmus of Central America.
Right, I understand. And Frank, what we want on this burn is 8 feet per second now. 8 feet per second. We want it radially upward, and we want you to use whatever thrusters are required to burn radially upward at 8 feet per second.
The sun is on both on the right side of the S4B. Why do you want to do so much, Mike? In our left number 1 window.
Because of the separation distance we would like to achieve between now and the time of S4B blowdown. And are you, when you give us those angles, that means that your plus X axis is pointed at it with those angles. Is that a friend?
Mike, you want me to go ahead and try to do this, or are you going to give me some gimbal angle?
Apollo 8 Houston, if you go ahead and do it without gimbal angles, if you can do that. Over.
Okay, I don't understand why you want so many feet per second out of it. I think I can, just a little maneuvering, I could get away from it a lot simpler than that.
So we're working on it, Frank. We'd like the radial upward for trajectory reasons, and the magnitude we'd like because of the separation distance, which we're predicting you'll have at S4B blown in.
Okay.
And plus Z quadrant. In other words, it's down below you on your right and slightly to your rear. Is that still good?
VHF sounds good.
Roger, under the VHF.
Mike, can you just tell us which way the S4B pitches and how far it pitches to the
Stand by. Your S4B is within 10 degrees of its fine latitude at this time. Go ahead. Okay, thank you for Y. I just got 4 digits, 0027. Thank you. Glad you gave me anything.
Omni B.
Understand, Omni B Baker. Would you give us an updated readout of your gimbal angles when your plus x-axis is pointed toward the booster, please? Apollo 8 Houston.
Go ahead, Houston, Apollo 8.
Roger, about 12 minutes before your big blowdown, there's a small continuous vent which opens at a GET of 455.55, and you may notice that on the booster. It's a 12, 15-pound thrust.
The roll read, okay, 105. The pitch.
And Apollo 8, could you give us your burn information whenever you have it?
We're maneuvering to the end now.
105,
Okay.
pitch 275, and yaw 325.
That should be 115 roll.
Thank you, 115 roll.
want 8 feet per second burn, is that right? Plus,
Like 8 feet per second, radially upward.
Plane towards minus X, over.
I understand the XY plane toward X, 45 degrees.
We're as close to being radially upward as we can determine. Plus Y
Roger.
minus X.
Roger, thank you.
It's behind us to the right, if that'll help.
Roger. Apollo 8, Houston, are you going to use P-47 to monitor the burn? Frank, what we want in this burn is 8 feet per second now. 8 feet per second. We want it radially upward, and we want you to use whatever thrusters are required to burn radially upward at 8 feet per second. Because of the separation distance we would like to achieve between now and the time of S4B blowdown.
Okay. Mike, you want me to go for that?
Apollo 8 Houston, if you go ahead and do it without gimbal angles, if you can do that. Over. We'd like the radial upward for trajectory reason and the magnitude we'd like because of the separation distance between the friction you'll have at S4B blowdown.
Maneuvering now. Okay.
Thank you.
VHF sounds good.
Roger, on the VHF.
Houston, we made the burn 7.7 plus X
small continuous
plus
event
0.0001 Y, and C's are all zero.
Notice that on the booster.
The gimbal angles roll 180, pitch 310,
Apollo 8, could
and
you
yaw
give us your burn
0
information
to
whenever you have it?
0.
Roger, copy plus X, 7.7, Y, 0.1, and roll, pitch, and yaw, 180, 310, and 20 per second, radially upward.
Did you get that information, Houston?
Apollo 8, Houston, how are you reading?
Read you loud and clear. Did you get the information?
That's affirmative. I say again, we copied plus X, 7.7, 1/10 in Y, no Z, roll, pitch, and yaw, 180, 310, 020.
Roger. Houston, we made the burn 7.7. The burn was made initiated at 4:45. These are all zero.
Roger, copy, 445, pig.
Gimbal angles roll 180, pitch 310, and yaw 020. Okay, you want us to transfer that to the CS, to the LEM state vector, or just leave it alone, Houston?
Apollo 8, Houston, how are you reading? Affirmative, Frank, we'd like you to transfer from the CSM to the LEM state vector. Copied plus X, 7.7, 1/10 in Y, no Z, roll, pitch, and yaw, 180, 310, 020. Roger, copy, 445, pig. We'd like you to transfer from the CSM to the LEM state vector.
power control that brings us up to the line of action at 4 hours, 49 minutes into the flight. You heard Jim Lowell say we'd have to postpone his cislunar navigation task, which involved plotting several stars, which had been planned during this last half hour. And in its place went the separation maneuver, an 8 foot per second separation maneuver to ensure adequate separation from the S4B. In the course of the last half hour, we lost, the ground lost lock with the beacon on the S4B, that was a VHF beacon. Our present altitude, their distance from Earth, is 17,200 miles, and they're still hearing VHF, which is being piped, music being piped by VHF out of the Goldstone, California
How's that
station.
booster looking now? Is it drifting away rapidly, or how's it
We're
looking?
asking him again about the booster.
Bill's
Let's
the only
listen.
one that can see it. Just a minute.
Okay.
We're 90 degrees from its x-axis, and we must be out 1,000 feet and moving up.
Do you understand? 90 degrees from its x-axis, about 1,000 feet and separating.
Plus or minus a couple of thousand.
Understand.
I think we've got clearance now. We got a little behind on our P-23, but I suggest we go ahead and start those now.
We've just heard from the command pilot, and he says they will resume the flight plan now with their navigation task. At 4 hours and 52 minutes into the flight, this is Apollo Control at Houston.
We're well clear of the S4B now, Houston.
Roger, Bill. Thank you. And at your convenience, could you give us a PRD reading? And as far as the P-23 goes, that's just fine to get started with it. It looks like your first star, which is number 14, should be good until about 5:15 GET. Over.
Roger. We'll start P-23. Apollo 8 with a PRD reading.
Go ahead.
Roger, at 4 hours, 4 minutes. Commander 0, CMP .64, LMP .02.
Roger, copy left to right, 0, 0.64 and 0.02 at 4 hours and 4 minutes. Thank you.
Roger, at 4:53 it was 0.01, 0.64, 0.03, and negligible on the survey meter.
Roger, thank you.
I have a beautiful view of the S4B and the Earth here on one. I'll try to get a picture for you.
Hope so. Apollo 8, Houston, we've got you about a minute away from the continuous vent open and 14 minutes away from the big dump, and we'd like an estimate on your distance now, if you can give it.
Stand by. This is about 3,000 feet, would estimate.
Thank you.
We can see the vent.
Apollo 8, Houston, say again.
Oh, we can see the vent.
Good, thank you.
Houston, Apollo 8.
Go ahead, Jim.
Boy, it's really hard to describe what this Earth looks like. I'm looking out my center window, which is a round window, and the window is bigger than the Earth is right now. We can clearly see the Terminator. I can see most of South America, all the way up through Central America, the Yucatan, and the peninsula of Florida. There's a big swirling motion just off the east coast, and then going over towards the east, I can still see West Africa, which is has a few clouds right now. We can see all the way down to Cape Horn in South America.
Good grief, it must be quite a view.
Yeah, tell the people in Tierra del Fuego to put on their raincoats. Look like a storm is out there.
Raj, will do. care to give them a 24-hour forecast?
Probably as good as any other.
This is Apollo Control Houston, 5 hours, 3 minutes into the flight. The spacecraft is nearly 19,000 miles from Earth, nearing the synchronous point, which it will start on through, of course. Velocity continues to slow. It's now 13,860 feet per second. In the last 10 minutes, we got another beautiful view type statement from the crew. We heard from both Lovell and Frank Borman. And the view indeed must be extraordinary. They describe the cloud cover over Africa, over all of South America, and the effects over much of North America. Frank Borman issued a special little weather warning. He suggested that the people in the Tierra del Fuego area at the tip of South America better get their raincoats out. Here's the tape of that conversation.
Apollo 8.
Thank you. Apollo 8, Houston, go ahead. Apollo 8, Houston.
Roger, you might be interested to know the center window is pretty well fogged up, but the other four seem to be pretty good shape.
Well, glad to hear you got 4 out of 5, and your big dump will be coming up in 2 minutes or so.
Roger, we're
I'm looking
standing
out
by.
my center window, which is a round window, and the window is bigger than the Earth is right now. We can clearly see the Terminator. I can see most of South America, all the way up to Central America, Yucatan, and the peninsula of Florida. There's the big Pacific Ocean that's off to the east of us. And then going over towards the east, I can see West Africa, and Nepal. We can see all the way down to Cape Horn in South America.
Good grief, I must have come with it. Right, real good. You care to give him a 24-hour forecast?
The S4B has started dump.
Houston, Apollo 8.
Go ahead, Apollo 8.
Roger, Mike, did you say star 14 was good about 5:30 something?
Yeah, stand by when I give you that time again. Star number 14 should be good for about another 8 minutes, Jim. 7 minutes.
Okay, now be advised, the optics calibration is very difficult to do because of all the other little stars floating around here. I'm going to ensure concurrent bypass and do it at the end of this.
Houston, Apollo 8.
Roger, Apollo 8, understand.
Roger, you might be interested to know the center window is pretty well fogged up, but the other ones are in pretty good shape.
Glad to hear you got 4 out of 5. You should have a lock stump now, Apollo 8. Will be coming up in 2 minutes or so.
Roger, we're standing by. The S4B is ready to go.
Well,
Houston, this is Ace. I'm looking through the scanning telescope, but that lock stump just blanked out completely. The entire scanning
stand by
telescope.
when I give you that time again. Understand.
It's a fantastic sight. It looks like the S4B has small attitude excursions while it's coming.
Okay,
Roger, understand.
Advised, optics calibration is very difficult to do because of all the other little stars floating around here. I'm going to ensure concurrent bypass.
Roger, Apollo 8, understand. Should have a lock stump now, Apollo 8.
Into the flight, and as we heard the crew record, the S4B is doing its propulsive vent. Now we should see a pretty dramatic separation between the two vehicles. The S4B will remain on a path which will take it, essentially, if you consider the moon straight ahead of you, for analogy purposes, it'll take it, the S4B to the right of the moon, while the spacecraft will veer in to the left. Slightly ahead of them. Earlier in that conversation, you heard Andrews reporting his PRD readings. That's the personal radiation dosimeter, and perhaps another dosimeter. They were down in the negligible range. anticipated they'd be, although the crew at this point has passed through probably the thickest portion of the Van Allen radiation belt as it departs the Earth. We'll continue to go through some residual background information on radiation out to about 40,000 miles. That's the new position in this flight. The flight controller name radiation has been instituted because of our passage through the belt. And at this point, we've heard nothing from him, which is about what we expected to do. At 5 hours, 10 minutes into the flight, this is Apollo Control, Houston.
Apollo 8, Houston.
Go ahead, Houston, Apollo 8.
I've got a flight plan update for Bill if he's ready to copy.
Stand by. Stand by. Ready to copy.
Okay, at about 5:10 GET, where we record the block data, TLI plus 4 and TLI plus 11. The TLI plus 4 pad that we gave you before is perfectly all right. We will not require that one, and we'll have the TLI plus 11 hour pad for you shortly. Then at 5:45 or 6 hours on that high gain antenna checkout. Roger, standing by.
We're on Omni D, and we heard we lost you after TLI plus 4 was okay.
Okay, the TLI plus 4 hour pad is okay. We'll have the TLI plus 11 hour pad for you shortly. And at 5:50 for your high gain antenna checkout, we'd like you to leave that switch in wide beam width to reference our conversation the other day. Leave it in wide.
Roger. Don't want to zap your receivers.
No, it has to do with some loss of tracking data, so it's better to leave it wide.
Okay.
Houston, Apollo 8, are you recording what we're getting out of 23?
Stand by one, Jim. I'll check. That's affirmative, Jim. We are copying your P-23.
Pretty big numbers there.
Well, we think that's because you bypassed the trunnion check.
Roger. Houston, we're getting some really big numbers in Delta R and Delta V.
I understand, Jim.
Suggest, do we want to proceed with this, or should we just leave them alone?
Apollo 8, say again?
Do you want us to accept these, or should we leave them alone?
Stand by. Apollo 8, Houston.
Go ahead, Houston.
Roger, we do not wish you to accept those marks. This is due to the fact that in bypassing the trunnion bias check, you still have big numbers left in those registers. So if you go ahead, after you do the trunnion bias check, then those numbers will become small later. But do not accept the marks now.
Understand, Houston.
And we have a TLI plus 11-hour update for you when you're ready to copy.
Stand by. Roger, ready to copy TLI plus 11.
Roger, Bill. TLI plus 11, and this assumes no mid-course correction, number 1. It's an SPS/GNN 63330 minus 163 plus 129er. Are you with me so far? Okay, 013 56 4759er minus 00489er plus 00000 plus 47250 177 144 000 not applicable plus 00197 47253 554 47050 12 1278 256 023 up 265 left 18. Are you with me so far?
Roger.
Okay, plus 119er7 minus 16500 12681 35608 0504653. GDC align north, set stars, roll 068, pitch 097, yaw 356, ullage none, other 1, fast return P37, delta V equals 7900 for Indian Ocean. Number 2, high-speed procedure not required. Number 3, assumes no mid-course correction. Number 1. Over.
All right, your TLI plus 11, SBS GNN 63330 minus 163 plus 129er 013564759er minus 00489er plus 0000 plus 47250. You copy so far?
Yeah, I'm with you so far. All the way, Houston, that's affirmative. I'm with you.
Roll 177 14400 NA plus 00197 47253 554 47050 1217 correction 256 023 up 265 left 18. Copy so far.
Yeah, I'm with you so far, Bill. Go ahead.
Plus 1197 minus 16500 12681 35608 0506 correction 0504653 north set 068 097 356 0 ullage note 1 fast return B37 Delta V 7900 Indian Ocean 2 high speed procedure not required 3 pad assumes no MCC1 over.
That's all correct, Bill.
Roger. Houston, Apollo 8.
Go ahead, Apollo 8.
Roger, Mike. I might give some comments on B-23 data. The auto maneuver was quite accurate. Looks like we got to the substellar point in the maneuver. Auto optics put Canopus right where it should be. Minute impulse control worked as advertised. At the altitudes at which I started to do the sightings, we have a definite hazy band line. The filter gives the Earth a glow, sort of an orangey glow. It's very indefinite of where to put the star. But there does seem to be a solid line where you might expect the horizon to be that appears through the haze where we expect the atmosphere to be. I followed the procedure which we had done up at MIT about utilizing the top of the haze layer as a definite line for these sightings. In regards to the optics calibration, it was very difficult to find the star in the landmark line of sight due to the venting of the S4B.
Roger, Apollo 8. We copied that, and we'd like you to do that trunnion check, that calibration, prior to your next set of sightings.
Roger, will do. Canopa's just disappeared from view, and maybe we get a little time here. I'll try and get a calibration the first thing.
Roger, understand.
And Houston, we've rewound the tape. You can dump it at your convenience.
Roger, Bill, thank you. Are you still picking up anything on VHF?
Are you playing anything?
Affirmative.
This is Apollo Control Houston, 5 hours, 33 minutes into the flight. We are now 22,500 miles from Earth, velocity 12,700 feet per second. In the course of his recent remarks, Jim Lovell said that it was he had a lot of difficulty finding the proper stars during his star
Roger,
checks.
thank you.
What's our altitude now?
Because of the competition of the S4B venting. Apparently that's setting off
You're about
big splashes of light
22,000
which
miles.
drown out the stars. However, they should be separating. At the last reading, they
Give
were
or take
3,000
1,000
feet
feet.
from the S4B,
I'll go ahead and turn
and that
the
distance
HFA
should
off
be
and
growing.
Roger, Bill, thank you.
The crew is just advised that they can no longer hear
That's
the
pretty nice music while
music
it
we've been piping
Yeah,
to
I
them
bet so.
by VHF out of California. The last report they were getting at 19,000 miles, we just queried them. They said they were not hearing it. We've got quite a lot of tape backed up. We'll play it for you now.
Apollo 8, Houston. Okay, we got about 5:10 DET where we record the block data TLI plus 4 and TLI plus 11. The TLI plus 4 tab that we gave you before is perfectly all right. We will not require that one, and we'll have the TLI plus 11 hour tab for you shortly. Apollo 8, Houston. 5:45 or 6 on that high gain antenna. We're going to have to wait until we get the high gain antenna locked on again to dump the tape.
We're on OBD and we heard the log chapter TLI plus 4 was okay.
Okay, the TLI plus 4
you about ready for us to go to the
okay. We'll have the
PTC
TLI
attitude?
plus 11 hour pad for you shortly. Stand by one. At 5:50 for your high gain antenna checkout, we'd like you to leave that switch in wide beam with conversation they leave it in wide. Yeah, it has to do with the loss of tracking data, so it's not a good point. Apollo 8, Houston.
Go ahead.
We'd like to hold off on the PTC and get some more P23 information. We'll have some more details of that for you shortly.
All right.
Mike, what I'm doing now, I'm going over to Star Sirius.
Apollo 8, Houston, you faded out completely on that, Jim. I heard Frank, but you faded when you began talking. Say again.
Roger, I've switched to Sirius. The second star, the first set, to see if I can't get an optics calibration on it at least. Here's the Apollo 8.
Roger, that's fine. We'll have some more good words for you shortly. Stand by one, Jim. Okay. That's affirmative, Jim. We are copying your P23. We think that's because you bypassed the tracking check. Houston.
Big numbers
Go ahead.
in those registers.
Jim, on your P23, we'd like you to go ahead and do the calibration and then use star number 15 and take 3 sets, followed by star number 16, 2 sets. Over.
Roger, Houston, that's what we're trying to do. I'm trying to get 15 for an optics cal. It's very difficult with the bright Earth to find a star that we can get into the section. I'm trying to use the auto optics in P23 to get the star. We have that now. We're trying to maneuver the spacecraft to bring the trunnion to 0 so we get the landmark line of sight.
Roger, understand. And also have your PTC attitude, which is different than you have. I'll give that to you whenever you got a free moment.
30 minus 163
Ready, copy.
plus 1.
All right, PTC attitude will be pitch 242, yaw 020. Over.
5 6
Pitch 242, yaw 020, copy.
9.
Very good, thank you.
Minus 0 0 4 8 plus 0 0 0 0 0 plus 4 7 2 5 0 1 7 7 1 4 4 0 0 0 5 3
find a star that we can get directed. I'm trying to use the auto eye.
TTC attitude will be 6,
Houston,
2,
Apollo 8
4,
order.
2, yaw, 0, 2.
Apollo 8, Houston, go ahead.
Roger, we'll hold up on a high gain check until we get out of P23.
Roger, Bill, thank you. May have to delay your lunch a little bit. Are you hungry?
No?
First time I've ever heard you say that. Are you hungry? First time I ever heard you say that. Apollo 8, Houston.
This is
Go ahead,
Apollo
Houston,
Control,
Apollo 8.
Houston.
Roger, looks to us like
5
your
hours,
S4B
52
is
minutes
behaving
into the flight.
completely normally in regard to all the blowdowns and other sequential events that take place. It looks good.
Delay temporarily
Roger, how
the
far away
check
is
out
it
of the
from
high
us now?
gain antenna.
Yeah, we were going to ask you.
Okay.
And that
50 miles.
Roger, copy.
we just got an estimate from the crew on the distance of the S4B. Frank Borman
Let's make that
estimates
80
50
kilometers
miles.
since it's an international aspect.
About 50 miles away, and then he corrected it and said, in view of the international aspects of this flight, let's make it 80 kilometers. Meanwhile, Lovell is checking his navigational programs and ensuring that you can see that, making sure that his optics are operating properly. At 5 hours, the high gain antenna, by the way, is of course of considerable interest to many of our data transmissions, including the transmission of televised data. So it was programmed to be checked out at 5 hours 40 minutes into the flight. It will be delayed slightly. We have 13 minutes. This is Apollo Control, Houston.
Okay, Houston, we did an optics calibration. We get zeros all the time.
Good, you understand optics calibration and zeros all the time. Good.
It takes a lot longer to do it, though. I had to go to a star like Sirius to finally see it.
Roger, understand. Oh, we're real glad you got that so we can get a horizon calibration term in the computer.
Like the number 5 window is starting to fog up, Houston.
Roger, Houston understands that the number 5 is fogging up.
23 coming through, Sirius.
Roger, Jim, thank you.
These numbers are a little better.
Oh, we would expect so.
Houston, how you reading Apollo 8?
Apollo 8, Houston, go ahead.
Roger, have you been getting the downlink on the P-23?
That's affirmative.
Okay, now how much longer do you want us to hold off going to the PTC?
Stand by, one thing.
Settled here in the control center on the first mid-course correction. It's presently planned as an SPS burn. Purposely wanted to get some early indication of its performance, the service propulsion system, and fortunately the other events seem to have worked in our favor. Presently planning an SPS burn of about 2 to 3 seconds duration, putting 24 feet per second into the overall velocity. And this event is presently scheduled to occur at about 9 hours into the flight. And let's see, beyond that, we still have no other indication of, we don't know any better just when the high gain antenna checkout will be made, but it should be done shortly. We have some tape from the last few minutes. We'll play it for you now.
Apollo 8, Houston. Apollo 8, this is Houston, over.
Roger, are you recording all of the data from 23, or do you want some read down to you?
Stand by, Jim. We think we're getting it all. We're confirming now. That's affirmative, Jim. We're getting all that's coming down. How's it going?
It's working very nicely. I finished one set with Sirius, 3 stars, and one set with Procyon, or 2 sightings. 3 sightings with Sirius and 2 with Procyon. All through.
Okay, Houston, this is Apollo 8. We're ready to go to the PTC attitude.
Roger, Frank, understand. And we understand you've completed all 5 sets, 3 on one and 2 on another in P23, is that right?
That's affirmative, but we've finished 5 sightings, 3 on 15 and 2 on 16.
Apollo 8, Houston.
Go ahead, Houston, Apollo 8.
Right, Frank. What we're doing down here is this. We'd really like for horizon calibration, we'd like a total of 15 marks, 3 sets on one star, 2 on the other. On the other hand, we're balancing that with the need to go to PTC, and we're not losing sight of the fact that you want to go to PTC right away. So if you could bear with us just another couple of minutes, we are trying to decide whether to ask you to go back and do some more P23 or whether to clear you at this time to go to PTC. Over.
Okay, we started maneuvering to PTC. We're getting kind of far behind is the only thing I'm concerned about, Mike. Jim is now taking off his pressure suit.
Roger, understand. How about you and Bill?
Well, we're standing by till he gets through.
Understand. And you are maneuvering to PTC, that's fine.
Well, I would prefer to do that, but we'll hand by.
All right.
What you...
Okay, stand by just one. 8, Houston.
Go ahead, Houston, Apollo 8.
Roger, we would like to hold off on the passive thermal control until 7 hours GET, and in the meantime to get as many more P23 marks as level can give us, starting again with the first star and doing 2 sets of 3 marks each, and then going to the second star we gave you, and concurrent with that, if possible, we'd like Bill to run this high gain antenna check out if Lovell's attitude is compatible with that. Over.
Okay, but they have not been to date. We're almost to the passive thermal control attitude now, and Jim is just halfway through taking his suit off.
Roger, understand.
We'll have to hold off for a minute here.
Roger, Frank, and the reason for this, of course, is the horizon calibration requires a number of points to give you good data for the onboard nav coming home.
Roger, we understand. We'll be right back with you. Just have to wait a minute here.
Roger, thank you.
Then failing to separate from the S4B kind of fouled us up there.
Understand.
8, how do you read?
Apollo 8, go ahead.
Roger. We're standing by. You about ready for the high gain antenna trial?
Okay, just a second, we'll check on that. And are you in a position where you can go back to the star sightings?
Well, we will be, but we can't until Jim gets ready.
Okay, we'll stand by and you'll give us a mark on that in just a second. I'll check on the antenna. Okay, looks like we're ready to go on the high gain antenna check. And we can either go with commands called out from the ground and you can monitor it, or you can be talked through it, whichever you prefer.
Well, stand by. I guess we're not quite in the proper attitude yet.
Roger.
We're slowly getting there.
This is Apollo Control Houston at 6 hours 29 minutes into the flight. At the present time here at Mission Control Center, we're in the process of changing shifts. Flight Director Milton Wendler and his maroon team of flight controllers are coming on to relieve Flight Director Clifford Charlesworth and the green team. We've had some brief conversations with the Apollo 8 crew, primarily concerning the onboard navigation exercises they're involved in at the present time. The crew attempting to sight on 2 stars, Sirius and Canopus, and take sightings, angular sightings between the stars and the Earth horizon. Conversations also concerned putting the spacecraft in the passive thermal control mode, and we expect shortly to begin some tests on the high gain antenna. We'll play back the tapes that we recorded of the conversations with the spacecraft and then pick up with whatever conversation is going at the time.
Right, Frank, what we're doing down here is this. We'd really like for horizon calibration, we'd like a total of 15 marks, 3 steps on one star, 2 on the other. On the other hand, we're balancing that with the need to go to PTC, and we're not losing sight of the fact that you want to go to PTC right away. So if you could bear with us just another couple of minutes, we are trying to decide whether to ask you to go back and do some more P23 or whether to clear you at this time to go to PTC. Over.
Okay, we started moving PTC. We're just kind of far behind him. I think I'm concerned about Mike. Jim is now taking off his pressure suit.
Roger, I understand. How about you and Bill?
We're standing by to see him through.
I understand. And you are maneuvering to PTC, that's fine.
I would prefer to do that before hand by.
All right. Okay, stand by this one. Apollo 8, Houston.
Go ahead, Houston, Apollo 8.
Roger, we would like to hold off on the passive thermal control until 7 hours CET, and in the meantime to get as many more P23 marks as level can give us, starting again with the first star and doing 2 sets of 3 marks each, and then going to the second star we gave you, and concurrent with that, if possible, we'd like Bill to run this high gain antenna check out if level's attitude is compatible with that. Over.
We have that man today. We're almost to the passive thermal control attitude now, and Jim is just halfway through taking it.
Roger, understand.
Last full off.
Roger, Frank, and the reason for this, of course, is the horizon calibration requires a number of points to give you good data for the onboard navigation.
Roger, we understand.
Roger, thank you.
And failing to separate from the S4B.
Understand. Apollo 8, Houston, you call?
Roger, there's high gain antenna on wide auto. Houston, Apollo 8.
Roger. Apollo 8, go ahead.
Roger, we're standing by. You ready for the high gain antenna trial?
Okay, just a second, we'll check on that. Are you in a position where you can go back to the start timing?
We will be, but we can't until Jim gets ready.
Just a second, I'll check on the antenna. Okay, looks like we're ready to go on the high gain antenna check. And we can either go with commands called out from the ground and you can monitor it, or you can be talked to it, whichever you prefer. Roger.
The present time, the spacecraft is nearing 30,000 miles altitude. The displays here in Mission Control Center show our current altitude at about 29,228 nautical miles. This is Apollo control at 6 hours, 35 minutes into the flight.
Houston, Apollo 8.
Go ahead, Apollo 8.
Are you getting the results you want from a high gain antenna?
Apollo 8, Houston, affirmative, we are getting your data, and we may have a beam width change, but stand by on that.
All right, we're standing by, and Jim is about ready to go back to the P-23.
Roger, we have a go until 7 hours on the start of the PTC.
Roger, 7. Houston, Apollo 8.
Go ahead, Apollo 8.
We're in a PTC mode now waiting for Jim. And I noticed that out my window now I can see Orion very clearly, even though the sun is bright in the other window.
Roger.
It almost pained me to say that, but it's true.
All right.
Speaking of windows, the number 5 window is getting pretty well obscured, and the number 3 window is unusable.
Roger, I understand number 3 is unusable and 5 is obscured. Can you make out any definition at all, or do you have a target to look at?
Well, I can see the sun. Wait till it comes around the Earth, and I'll give you a better hack on that.
Okay. Apollo 8, Houston. We're going to go ahead and try to dump your tape right now. The circuit margins aren't too good in our present configuration. We're going to take a look at it. If it doesn't work, we may have to dump it again in a later configuration.
Roger.
Houston, Apollo 8, we're maneuvering back now to do another P-23.
Roger, thank you.
Houston, this is Apollo 8. I'll do 2 more sets on 15, and then we'll go 1 set on 16.
All right, thank you. Apollo 8, Houston.
Go ahead, Houston, Apollo 8.
Okay, Apollo 8, I'd like to fill you in on things we're thinking about doing in the next couple of hours, first chance you get there.
Go ahead.
Okay, in relationship to the mid-course correction, we'd like to put that one off until about 11 hours, and it'll be approximately a 25 foot per second burn. The reason we're delaying the burn time is to allow for better tracking. As a result of the 7.5 foot per second you put in on the separation, why we'd like to take a little more time and look at the tracking data. And the dispersions in your correction aren't going to be growing very fast here. What we'll do then is to delete the nav sightings that occur about 9 plus 10 in the flight plan, and this will be getting us back onto the normal flight plan sequence. So we'll go ahead and finish the P-23, and the 7-hour limit on that P-23 is due to the range limits on this test. Over.
Is due to the what, you say?
The 7 hours on the P-23 problem is due to the fact we want to get these sightings in at a certain range. Over.
Roger, understand.
If you have any comments on that proposal, why go ahead and pass them down and we'll feed them in.
No, I think that's fine. We need to get out of suits and get something to eat here, too.
All right. So looks like we'll be back on the flight plan by the 11 hours. We'll be holding up on the updates and pads because of the later burn.
Houston, Apollo 8.
While we're apologizing, I
Go
guess
ahead,
I
Apollo 8.
apologize again for all those crazy numbers I gave you after
The
TLI.
S4B
A guy was was calling out a projection, and you know, if you stop burning right now, you'd have an apogee of 60,000 miles, 90,000. And I guess I was hearing those in one of my several ears, and I just did a transponder. And oh man, I worked in a lot of good things. Fortunately, you didn't know. But I am sorry, I hope the record's been properly purged. Yeah, well, we're settled down now, and part of our problem, I don't want to blame IBM or belabor the thing, but one of the problems we had this morning, that kind of information was really critical. and we're working with a data display thing, and I get the channel, and then the computer decides to change the channel, and it changes it to, say, the ECS readings, which I don't need. So then I hit the TV guide to find out what the new channel is, and then, and then it changes again, so we're constantly trying to now how to work with it. I'm in knowing about every announcement. I think we ought to hit it at least a couple times an hour. It's a running thing. The distance from Earth and the receding feet per second. The distance will always be in nautical miles. Velocity always in feet per second. And if there are no further questions, are we ready? Okay, I think we've gotten off to a very good start here. We got a little behind in the flight plan, I think, after TLI, but I think that's going to sort itself out shortly. To recap, I don't think the launch phase could have been any prettier from our point of view. Everything looked great.
Houston, Apollo 8, are you getting the data from the P-23
and put us...
Stand by 1.
Oh, I'm sorry. I'm Cliff Charlesworth,
Apollo 8.
flight director on Apollo 8, one of them. To continue, I think the booster did its usual fine job. The insertion was almost perfect, something like 99/103, targeting for a 100-mile circular. That's pretty good workmanship. Nothing else, I don't think of significance in launch phase. We seem to have reasonable communications all the way up. As far as the Earth parking orbit phase, everything appeared normal to us. You probably heard the exchange concerning the O2 high flow. This, we think, is the same thing that we went through on Apollo 7 with the dumping through the waste management and so forth. It's going to cause a little O2 high flow, and we expect that to stop somewhere around 8 hours elapsed, plus or minus of that. So we don't see any problem with that, and there's no concern. Coming across the states, we passed up a large number of updates and numbers, and I think you'll hear a good deal of this on the flight. These are the maneuver pad updates that we'll pass periodically. Everything looked good all the way across, and coming up across Carnarvon, we were all satisfied that the booster was in good shape for TLI and the spacecraft. TLI burn itself was again mostly replica of launch phase. In fact, it might even been a little better. All of our data indicated things occurred within 1 or 2 seconds of when we had predicted them to occur. The cutoff itself was very, very good. As I recall, the estimates were, in terms of mid-course, was something like 9 to 10 feet per second mid-course maneuver required. Now, I'll talk some more about that later. Following TLI cutoff, the booster again properly sequenced through from its IU computer and went to the proper attitude within a few degrees. Everything normal on the booster. Spacecraft following the burn again was all normal, and the separation maneuver was performed on time. They separated, turned around, and did the formation flying for a few minutes, and initiated the 1.5 foot per second separation maneuver approximately on time. Now this is where we ran into the first little surprise of the day, and I'm sure we'll find some more surprises before we get back. For some reason, and I don't know the answer yet, we'll have to try to piece it back together. We didn't quite get the separation distance we were looking for following that maneuver. This could have been caused by several things. So we started looking toward doing another additional maneuver to get a little more separation distance from the booster prior to its dump of the remaining propellants. We did this maneuver about 8 feet per second with the RCS. We then were getting an opening between the two vehicles.
A dump occurred on time from the booster. All that appeared to be normal. From that point on, we went into the remainder of the flight plan, and this negotiating back and forth, trying to sort out exactly where the booster was relative to the spacecraft, got us a little behind in the timeline, and I'll say again, I think we'll be catching up to that pretty shortly and be back on schedule. That's really about all I have. The spacecraft looks good in all systems, all areas look good in the spacecraft. The booster is essentially through with this mission, and it's done a magnificent job. We will try to track the booster and have been tracking it. We will try to get a vector and possibly in a few hours be able to determine something in terms of what its trajectory will end up being. I guess that's about it. I think it's been a real fine day so far. Seems like a long one to me. And I think we're off to a good start. Mike, you got anything there?
No, I don't think I did tell you that.
I'm sorry, let me say a couple more words about the midcourse. We were scurrying around with the second separation maneuver, and we finally determined to burn 8 feet per second. We were looking at a 7 or 8 foot per second midcourse with the RCS eventually anyway. What we think we've gotten ourselves to now is that we'll probably have a midcourse maneuver somewhere from 9 to 11 hours, and the magnitude would be some 24, 25 feet per second. If this holds up, and again we have to track it for a little longer, we'll probably do this maneuver with the SPS engine and best get a check with the service propulsion engine prior to doing it all. So we expect, and they'll work on this for the next couple of hours to home in on when to make the midcourse, what size, and with the SPS engine, and we'll be back through the current trajectory.
So it has to be the greatest put down in America of all time. As soon as we find the Earth, we're being grounded. Just love that. Smug, yeah. Okay, any questions? Henry? Wait for Mike, huh?
Why was the astronaut not use early suppression? 8 foot per second at the Earth?
Well, his problem was that he wanted to keep the booster with you when he didn't move it. And I'll admit it got a little confusing. We were trying to figure out the best way to do that in terms of gimbal angles and magnitudes. So it took a while to sort that out. That was his concern, was that he wanted to keep the booster in view when he didn't move it. We finally elected to increase the magnitude of the maneuver because we used some time sorting this out. And so we increased the magnitude to be sure we'd get some separation distance. Velocity was in radial direction, which is like so, away from the Earth.
About this, it seems to me that the quality of radio communication from the spacecraft is much clearer, much more intelligible this time than any mission that I can recall. I'm wondering if you can explain this. I think it's not something that I noted alone. Everybody's been talking about it.
No, I think it's just like all other phases of the space program. We're getting any bugs that we've had, they're getting ironed out, and we're hitting the point now where we can expect very good communications, other than perhaps a very brief period during the boost phase when the spacecraft is going through the high subsonic or high Q region.
Well,
We're on the USB system too, and that one I believe in Apollo 7 was very clear, at least most of it that I heard.
better than Apollo 7. Certainly we haven't made that call until just in the last 2 months. Doesn't it have something to do with the fact that you're getting away from interference on Earth or anything like that?
Can't answer that.
First rev release, which we ran into in 7, where we lost it over the Vanguard, and then it jumped right up the edge in the first rev in 7. And we had a little of that this time at the Monterey, one of these stations. It just didn't quite come.
I think you've got a good point. I think it's better since we've gone up and it wasn't much orbit. It seems to me. From our communications perspective.
We should have comms so good from the simulator.
If there is a technical explanation for this that some communications expert could come up with, could you get it for us and just pass
Surely.
it?
Mm-hmm. And I'm sure there must be.
In view of the slant of your question, I'm sure they'd be happy to respond.
Okay.
Was any attempt made after S4B separation to simulate a docking maneuver? If not, would this have been possible? Were the rates of the S4B too great to simulate this maneuver?
No, we didn't make an attempt to physically dock. They were scheduled to move in fairly closely and take photographs and evaluate that sort of thing, but not in the sense of actually moving into a dock. But they did turn around and should have moved close and take a photograph. Yes, the booster attitudes are stable.
Is the reason for making this mid-course with the SPS primarily a fuel consideration?
Well, there's a crossover point depending on the weight of the spacecraft to choose to go either RCS or SPS. If you're over something around 12 feet a second or so, we would prefer to go SPS. In addition, this gives us a test of the SPS engine.
Go ahead, Houston, Apollo 8.
Hi, Raj. We're copying your P-23 progress, and FAO advises that looks like you're finishing your first star, and we'll need one more set on the second star. And this 7-hour cutoff isn't that firm, so we'd like for you to go ahead and complete the second star if you can.
You'll have to come up here for questions, sorry.
And
We're on the last sighting of the second star right now.
okay, real fine.
George Alexander.
And we've got
for Mike Collins.
about time
Mike,
for a
can you tell us
cryo
how
fan
you
cycle.
felt, since you were once a member of the crew, how you felt when you gave the
Okay, we'll do
Apollo 8
one
crew
at a
the
time
go
for,
for TLI?
About 4 minutes, now that's done.
Raj.
Oh, it was a great feeling. I never had any doubt that we'd be able to give them a go for TLI, and of course, I think we were excited on the ground about it very much. So I'm sure they were on board the spacecraft, although they came back rather matter-of-factly. I think, as you know, that tends to be the case in these flights when there are a long sequence of fast-paced events laid together. The crew is always looking toward the future. And I'm sure right after the TLI burn, although they were very impressed by the fact they were on their way, their attention was devoted forward in the flight plan to the next tasks coming up for them.
Mike, what I meant was your own feelings about not being with them at that point.
All right, Bill.
Well, I think I was in the second best place to be, I'll put it that way.
Houston, Apollo 8, we just got finished taking 2 sets, 6 sightings on Sirius, and one set on Procyon.
Jack Jones, State News. Why is the mid-course going to be...
Roger, understand that's 6 on Sirius and 1 on Procyon.
What's the meaning for
2
this?
sets on Sirius, 1 set on Procyon.
Roger.
Okay. You mean the post-launch when we were indicating something like 7 or 8, 9 feet per second? If that's the question, we did the extra separation maneuver from the booster to get distance prior to the dumping. This energy added to the orbit has caused the mid-course to increase to somewhere around 24, 25 feet per second.
As part of Newsweek, I want to be clear whether the SPS, whether the burn that you made to separate, the second burn, was made with the RCS.
Yes, it was made with the RCS.
The mid-course burned as a test of the SPS, is that correct?
Well, we'll combine things. We'll need to make the mid-course and we'll use the SPS, so this will give us a good test of it.
And Apollo 8, when you get a chance down in the lower equipment bay, looks like you're using the floodlights in the dim 2 position.
Questions from here.
And that one is a time limited item. We'd like for you to do your standard running in the dim 1 position. Over.
Roger, just turn
Walter,
them
do you have your hand up?
Okay, anytime you have them on, running dim 1 position is preferred for the LED.
If you understand it, then. Sir? Yes, I thought nobody had ever asked the price of the flight. Is that? Okay, thanks very much.
Houston, we have the cryo fan on the number 1 H2 tank. It was on at 0701. You give us a hack when you want, when you're ready for it to be turned off.
Will go. Okay, Apollo 8, you can terminate that one and go to the other tank.
Roger. Okay, H2 number 2 is on.
Roger.
Okay. Houston, Apollo 8.
Go ahead.
Are you having any problem on the ground with your comm?
Negative, you're coming in loud and clear.
Okay, we seem to be breaking lock intermittently up here once in a while.
All right, we'll keep our eye on it. Sounds good, though.
Okay, we've initiated PTC.
Roger. Okay, Apollo 8, you can terminate the fans and hydrogen, and we're ready to start on the oxygen tanks.
Okay, stand by.
We're through with the adult. You can have the tape recorder back.
Good data from the high gain antenna. At least preliminary indications are that it is working as planned. The crew is scheduled to come up shortly on an eat period. They'll be getting their first meal of the mission in space. And they also, prior to that time, plan to get completely out of their suits. We have some tape of the conversation. We'll play that back for you now.
Go ahead, Apollo 8. Houston, primitive, we are getting your data, and we may have a beat with change, but stand by on that. We have a go until 7 hours on the start of the PTC. Houston. We're going to go ahead and try to dump your tape right now. The circuit margins aren't too good. Present configuration. We're going to take a look at it. If it doesn't work, we may have to dump it again at a later configuration. Right here. Houston, Apollo 8, we're maneuvering back now to another P-23. Roger, thank you.
Apollo 8 Alpha, 4 on 15.
Right, thank you. Apollo 8, good. Okay, Apollo 8, I'd like to... Apollo 8, Houston. We're ready to go to the second O2 tank. A couple of hours, first chance to get there.
Go ahead.
Okay, and for your information, Cleveland 24 to 10. We'd like to put that one on. And what we plan to do, it'll be approximately a 25 foot per second burn.
Say again?
The reason we're delaying Cleveland 24 to 10.
To allow for better
Not over yet.
As a result of the 7.5 foot per second you put in on the separation. Why, we'd like to take a little more time and look at the tracking data. And the dispersions in your correction aren't going to be growing very fast here. What we'll do then is to delete the nav sightings that occur about 9 plus 10 in the flight plan. And this will be getting us back onto the normal flight plan sequence. So we'll go ahead and finish the P-23, and the 7-hour limit on that P-23 is due to the range limits on this test. Over. The 7 hours on the P-23 problem is due to the fact we want to get these sightings in at a certain range. Over. If you have any comments on that proposal, go ahead and pass them down and we'll feed them in. All right, looks like we'll be back on the flight plan by the 11 hours. We'll be holding up on the update pads because of the later burn. Go ahead, Apollo 8. We're copying your P-23 progress, and FAO advises that looks like you're finishing your first star, and we'll need one more set on the second star. And this 7-hour cutoff isn't that firm, so we'd like for you to go ahead and complete the second star if you can. And okay, real fine. And we've got a stop time for a cryo fan cycle.
One site
you're using the floodlights in the dim 2 position. And that one is a time limited item. We'd like you to do your standard running in the dim 1 position. Okay, anytime you have them on, running dim 1 position is preferred for the LED. Okay, Apollo 8, you can terminate that one and go to the other tank. Okay, number 2 is on. Okay, Apollo 8, looks like you can terminate your cryo fans now. And we're going to leave you alone for a while, let you get caught up. Things we have on board, the high gain antenna check, the comm mode check that you have listed at 7 hours, we'll put off and do whenever you're ready for it. So that's at your convenience. During the high gain dump that we performed using the wideband, we were still getting real good data at 36K, which is a little bit further than circuit margins that were predicted for you. And we've got our SPS burn coming up somewhere around 11 hours, and we'll give you more information on that later. You can terminate the fans and hydrogen, and we're ready to start on the oxygen tanks.
We're doing the program 21 now, determining ground track for LOIs that we did not make at 5 hours.
All right, thank you. We're through with the dump. You can have the tape recorder back. Apollo 8, Houston. We're ready to go to the second O2 tank.
Okay.
And for your information, Cleveland 24 to 10. And what we plan to do... Second. That's Cleveland, 24 to 10. Not over yet.
Thank you.
Okay, Apollo 8, looks like you can terminate your cryo fans now. And we're going to leave you alone for a while, let you get caught up. Things we have on board, the high gain antenna check, comm mode check that you have listed at 7 hours, we'll put off and do whenever you're ready for it. So that's at your convenience. During the high gain dump that we performed using the wideband, we were still getting real good data at 36K, which is a little bit further than circuit margins that were predicted for you. And we've got our SPS burn coming up somewhere around 11 hours, and we'll give you more information on that later.
Roger. We're doing the program 21 now, determining ground track for LOIs that we did not make at 5 hours.
All right, thank you.
During that conversation with the crew, you heard Frank Borman refer to the windows on the spacecraft clouding up. He mentioned that the number 3 window was completely clouded over, and that the number 5 window was partially clouded. Those windows, as seen from the inside of the spacecraft, number from 1 to 5, beginning with the commander's side window, left-hand side of the commander's couch. Number 2 window would be the docking window above the commander's position. The number 3 window is the hatch window. Number 4 would be the docking window above the command module or the lunar module pilot. And number 5 would be the lunar module pilot's right-hand window. You also heard some references there to P23. This refers to a computer program and indicates that the crew is involved, or refers rather to onboard navigation activities. We've had no other conversation with the crew, and we anticipate that they will be involved in eating shortly. This is Apollo control at 7 hours and 25 minutes.
Houston, Apollo 8.
Go ahead, Apollo 8.
Okay, we just broke lock on this, man. High game. We're on Omni B now.
Roger, Omni B. Apollo 8, is that Bravo or Delta?
Dog, Delta.
Roger.
We can't get the program 21 to integrate up to LOI. It just stalls out around 69 hours and 2 minutes.
Guidance. Roger, they're watching.
Houston, Apollo 8.
Go ahead, Apollo 8.
Roger, do you want us to stop the integration via verb 96 over?
That's affirmative, verb 96.
Roger, will do.